Hello. Tonight we're going to talk, or today we're going to talk about simplifying radicals. Okay, this is something that you covered last year in Algebra 1, but those of you might not just remember how to do it, so we're going to go through the process. Now, when we're simplifying radicals, I'm not asking you what the decimal equivalency is. I actually want you to simplify these. I want these in simplified form, which means there should not be any perfect square factors within the radical. Okay, so the radical is the square root, okay? And what we're going to do is use something that you guys did, probably back in elementary school. So we're going to go back a little ways, and we're going to do factor trees. Okay, so factor trees are where we have a number and we say, what two numbers when multiplied together give me 27? Okay, and I would say, oh, that's 9 and 3. And some of you will remember, okay, 9 is a perfect square, and I can just start with that. But I actually want you to take it all the way down to those prime numbers. And so I want you to say, okay, 9, because it's a composite number, we can, that is composed of two additional factors, and those are 3 and 3. Okay, so I've got the square root of 27, and I can rewrite 27 as the square root of 3 times 3 times 3. Okay, well, when the index here is a 2, and because there's no index given here, we assume a 2. That's why we read this as the square root. So the index is 2. Okay, if it was something else, it would be like the cubed root of 27. Okay, and that would be a 3, meaning that's your index. But when there's no index given, we assume it's a 2. Okay, so what we're doing, that index tells us what we're looking for. And we're looking for factors, pairs of factors. We're looking for groups of 2. Okay, groupings of 2 of factors. So I have one grouping of 2 here of the factor 3. So because I have that, I can bring out that 3 to the outside of my radical, and then underneath it, I'm going to be left with 1, 3. So this is really 9, and the square root of 9 is 3. That's where this comes from. And then this 3 doesn't have a match, so we're going to leave it underneath the radical. So the simplified form of the square root of 27 is 3 times the square root of 3. Okay, what about 392? Well, that one's going to be a little bit more involved. So we're going to start by dividing it by 2. 2 goes into 392. And so we'll go through this process, and 2 goes into 3 once. And you guys probably have calculators, so you can do this a little quicker than me, but I don't have one on me. 8, and then bring down that 2. 2 goes into 12, 6. So 196. Okay, so now I know that's also divisible by 2. 2 goes into 196. How many times? 2 goes into 19 8 times. Oh, no, sorry, that should be 9 times. 9 times 2 is 18. Subtract 1, bring down your 6. 2 goes into 16 8 times, so 2 and 98. Okay, well now this is 2 and 49, and 49 is 7 times 7. So when I rewrite 392, I'm going to write that as the square root of 2 times 2 times 2 times 7 times 7. Okay, and now because this is the square root, I'm going to find pairs of numbers. So I have a pair of 2's and I have a pair of 7's. And because I have a pair of 2's, I'm going to bring 1 2 to the outside, and I have a pair of 7's, so I'm going to say that 2 times 7. And then underneath my radical, I have this one lonely 2. It doesn't have a match, so it's going to stay underneath the radical. 2 times 7 is 14, so I have 14 times the square root of 2. Okay, so you have few problems to practice in simplifying radicals.